Hi guys, welcome back. Uh, Today we're going to discuss, we've been doing this series of some questions, learning the concepts with the help of questions. And in the previous session, we have selected out of all who are responding in the chat, out of all of them, we have selected one person from the YouTube live. I have selected one person who is responding quickly, and we offered him a job. We sent to an interview, and he's now selected. He got selected from the previous live session. We took some persons. Out of those, one person is having all the eligibility criteria. I said one of the eligibility criteria, sir, he must be a PiSquare students. So we sent him and he got selected finally. His offer letter is, he received offer letter. Okay. Now it could be your turn afterwards. Okay. So what all you need to do is, whatever you know, of course, now, right now we don't have that position for this live, but I'll be definitely keep coming with such offers. If some people are approaching us, we'll forward that definitely to you. We'll try to pick the best person. You're sending your details on the WhatsApp, it's not going to help. Okay, what is going to help is your performance in the live session is going to help you. Simple. Anyways, let's get to the first question. So we have some interesting questions today. Coming to the first question, we have some questions based on three-phase transformers. Okay, I hope you'll be able to solve. I'm just taking you through the overview of the questions. Okay, yeah, these are the questions what we're going to see in this session. Okay, let me just start from the first question. Yes, here you go. I think you know the drill. You'll get 1 minute time. Within 1 minute, you should be able to answer it. Yeah, simple ones. This is one of the popular questions. People do get confused here. Let's see how many of you correctly answer this. Tarun, hi, Tarunji. Okay, nice. We're getting some really nice answers. Five more seconds. So I think responses are low. Sampath is back. Durga Prasad is back. Nanu is back. Okay, guys. You guys are back, but the responses are slow. I don't know why. What happened? Come on, cheer up. Delta to star. Kranti Kumari is back. Chandra Babu Naidu. Ex-Chief Minister also is there in the chat. Transformer connection at the sending end of a transmission line is usually Kranti Kumari is saying delta 2 star. Okay, we got one response, that is delta 2 star. I'm not saying this answer. I'm just marking one of the common confusions one may have. Okay, which some people are actually doing it. I'm not saying this is right answer. Okay, this is commonly confused. People normally go with this answer by thinking delta 2 star is suitable for, because transformer connection at the sending and the transmission line. At the sending and transmission line, we need step up operation. What is that we need? We need step up operation. See, marking answer and going to the next question is not my motto. Giving the details of that is also a key motto. Okay, so I hope you're understanding that. So my focus is on explaining why it is the answer. So sending and voltage, we use step up transformer. Okay, we require step up transformer. So what is the best suitable transformer for step up operation? For step up operation, what is the suitable transformer? Upcoming CM also. Okay. Upcoming CM. Is it not Pawan Kalyan upcoming CM? Is it Chandrababu again? Anyways, let's not divert. Yeah. Step up. Yeah, tell me. Step up operation. What is the best transformer? I want your chart. Come on. Drop some. Drop some. Drop some. I want your answers. I want you to drop some answers. Come on, type something, guys. Yes, good. Drop it. I want more. I want more. Guys, yeah, I think one more update. You're checking our WhatsApp channel, right? Which is pinned in the chat, which is pinned in the comment also, where we're updating all the job updates. Andhra Pradesh lecturer post, Polytechnic lecturer posts are coming soon. We can expect Polytechnic lecturers very shortly. Okay, so whatever it is, guys, you need to don't wait for the notifications are coming up. We already gave an update for TSGENCO also. Polytechnic lecturers also coming up. It's time, it's your time, it's a high time. It's high time to start your preparation. Okay, yes, great. So all your responses are right. All your responses are right. So here, this is for, here suitable transformer is definitely delta to star transformer is suitable for step up operation. Step up operation. Yes, somebody is saying because secondary side high voltage, so if you take star it is better. That's true. But here there are two reasons. There are two reasons why we use at the sending end, we use star delta, not delta to star. We use star delta, not delta to star. Web node came. What is that web node here? Which one web node you're talking about, Vamshi? Which web node you're talking about? Tell me. We'll check that also on this on the spot. Star delta. Now, what's one of the main reasons? One of the main reasons why we use star delta for step up. In spite, this star delta is most of preferable. It's not most preferable or something like that. It will be, for step down, it is suitable. Okay. So what's the main reason? Tell me. We are saying step up operation. This is good. We need step up operation at sending end. But why are you going for star delta at this position? Yes. For same phase voltage, phase delta voltage, for the same voltage, phase voltage, delta will have more than star. No, not at all. That's reverse, Ritesh. How can we conclude it must be step up? Then I think you have to adjust your, maybe you have to have basic idea of this power system. I think in our free videos it is there, Tarun, you have our free videos. You can just go through our courses.pa2.in, or maybe you can download our app, okay, which is there in the description, and check any one course in their power systems. Free videos are there. Some parts of free videos will be there. Not all videos are free, okay. If you watch that first free videos, you will get an idea of why it should be step up, okay. So you can go through online tests or whatever. We have books also, physical books. Right now, one book actually. Another book, it is getting ready. You will get it soon. So come on, we are a reason. We are talking all this is whatever the reason. Star delta. Reason is protection purpose. You are having a generator. Generator is there here. Now, from the generator, you are using a step-up transformer. This is neutral grounding is required. Here, you'll have to go for the neutral grounding. You'll have to go for the neutral grounding. You know why neutral grounding should be there. And for the continuity of the path, here also this must be star and this also must be grounded. Then whatever fault currents are flowing, it will have proper protection if you have this kind of configuration. So it must be star. Then the other side, delta. Okay, so 3 transmission line, 3 wires will go. Of course, star also can have 3 wires. Okay, because if you go for 4 wire system, neutral also when you're transmitting, unnecessarily 4 wires, long distance transmissions. Why to go for that? Okay, this is one of the key reasons. If you have any other reasons, you can let us know in the comment. Okay. Yes, polytechnic lecturers notification already వచ్చేసిందంట. Great. Yeah, we'll come to that. After this session, we'll immediately come to that session also. Okay, just few more questions are there. Now coming to this. I think it's the question. I mean, you got this, you understood this point, right? Let's go to the next question. Great. I think this everybody can answer and people are answering it nicely. Great guys, let's not spend too much time on this. Yes, it is C. The transformer is not used in DC because obviously, tell me the reason now. I think everybody is saying the reason. Now. Now tell me, what is a problem? Of course, the reason is it should not be used because rate of change of flux is d phi by dt in case of when you are giving a constant DC is 0. Now tell me, what is the consequence? Is it just it is not going to work, or will there be any damage? Tell me in the chat. Just tell me in the chat. You tell me, will there be a damage or it won't work? Yes, Nanu has said it already completely. Winding will burn. Winding will be burned. To be more precise, Nanu has said primary winding will damage. Nothing will happen to the secondary winding. That's more specific one. In the interview also recently, I said, right, we sent one person to an interview. He went to an interview, he cracked the job. Okay. Now he was hoping for the getting the job. He went to the interview. Now there you have to give not just it will damage. No, it's not going to help. It should, in the interview, your objective is what? Your objective is to showcase your knowledge, showcase your intellect, not to just answer to the question. You have to present your knowledge, what are the knowledge you have. So when he asks a question, you deliberately have to explain in detail onto that by using the terms what you exactly know. Don't unnecessarily bring the new terms which you don't know. Okay, great guys. Great. So we're having Vishnu Teza. Vishnu Teza is asking a question. What's the best rank we got from PiSquare Academy? This is the only year we launched completely full course for the gate. This is a year, okay, for 2023 gate, and we got something, I think 172 rank, I think 172 and 271 rank, another rank. Okay, hey, guys, come on, what the rank, all these ranks, these, that's fine. You just go to the start of the video and watch the video first. Okay, watch the promo video or the PiSquare style. There you will understand what, or else go to our website, try to watch the free videos, explore it, and tell me who is in India, who is doing that. In India, is somebody else is doing that? No one else is doing that. Then, anyways, so I think this is clear. Primary winding is going to get damaged. That's true. You're absolutely right, guys. You're absolutely right. Next one. Next question. Go for it. Great. Durga Prasad. Pritesh. Yeah. Time's up. Time's up. Time's up. Now let's see. Let's see what is asked in the question. In the question, it is said about in a three-phase transformer used in distribution system. Tell me which transformer is used in distribution system. For the distribution system, what is the transformer used? Tell me, come on, distribution. For the distribution, what we require? We require 4-wire system or 3-wire system? We require 4-wire system. So definitely secondary must be star. Secondary must be star. So, and in the transmission you are sending from delta, so it should be delta to star. In delta to star transformer, I think we have amazing video for this vector grouping, concept of vector grouping. For the vector grouping, in the vector grouping, I have clearly described with amazing animations. You will understand if you watch those free videos on the YouTube. Vector grouping PiSquare Academy, type it, you will get a complete videos. 3 videos will be there. You'll get a clear details of the vector grouping. Okay. Now, which transformer? Suppose I have delta to star transformer, I'll be using for the distribution system. Okay. Now, what is a phase shift it will have? The question is, what is a phase shift? What is a phase shift? Phase grouping is little different. Phase grouping is, vector grouping is, it is with respect to the phase voltages. Phase voltages. Now, he is saying what is a phase shift means for the line voltage. Or let's take it as for the phase voltage. Or let's take it of he is asking about phase grouping. Now tell me what are the possible things for delta to star. For delta to star, what is a possible phase groups? What is a possible phase groups? And out of all these groups, which one is matching here? Which one is matching here? For this, I think this is, what is this phase grouping? This phase grouping is 3 and 9. 9 and 3 is a phase grouping for this. For this, 4 and from here it is 8. This is a phase grouping for this. If I had to vector grouping, okay. This is 1 or 12. You can say anything. Not 1 or 12. Sorry, it's 0. It is 0. Phase grouping 0 is this. Okay. This is 1 or 11. Now, delta star configuration can have, it can fall into vector grouping 1 or maybe 5 or maybe 7 or maybe 11. Out of all these given options, 1 means 30 degrees plus or minus 30 degrees. This is it, matching it. So 1 is 30 degrees clock. If you just put that, this is the angle for 1 o'clock. For 11 o'clock, it will be somewhere over here. I mean, it's 11 o'clock. One is this way, another one is this side. So answer is plus or minus 30. So if you want to answer this, you should have a clear idea of delta to star means you have to remember this 1, 5, 7, 11. And you remember this, remaining things will be automatically, it will be done because this is one of the key things. Okay, this is one of the key things. Suppose zigzag, star to zigzag star. Star to zigzag star also will have 1, 5, 7, 11. Okay, star to zigzag star also will have this. If you have any questions, you can ask me in the chat. Let me just take 1 is minus 30, 11 is plus 30. Very good. dy 1, 5, 7, 11 is possible. Wow, kya Tritesh, amazing, amazing. Tritesh has given exactly the same thing. Okay. Then our load current must flow two directions, but we consider one direction only. Why? You're right. You're right, Rudratesh. I think when you're asking this question, it's pretty much clear that you're not a PiSquare student, because in the PiSquare, we deal everything right from these kind of questions, these kind of intellectual questions, interesting questions, the basic question set. We'll address all of those. Plus minus, they're continuously changing. Polarity is continuously changing. Current is going one way this way, another one is this way. When the alternate current is changing, why only give current arrow in one direction? If anybody can answer, it will be great, because I discussed those things with the animations in the course. Okay, I'll be happy to hear from any one of our students. Anyways, coming back to this, what if it is star-star? Star-star connection, what are the possible vector groupings what we can have from star-star? Yes, I want to hear it from you. From star-star? Yeah. Are you giving the chat? Type. Simple one. For star-star vector grouping. See, vector grouping concept, come on here. Watch the free videos from the PiSquare I'm saying. What's the problem? Great. 0, 12, 0, 12 both are same. 0 o'clock or 12 o'clock. 0 and 6 either in phase or 180 degrees. Yeah, 6, 12, you're right dear, you're right. 12, 6, you're right. Okay. Now tell me, what about a DD? And I think you can frame other things. DD, YD, all these things you can frame. Okay. DY also same, YD also same. If it is YD, that is also same. Okay. 1, 5, 7, 11. Okay. Clear details you will never get anywhere except in PiSquare about the vector grouping. You will get a clear-cut idea. Watch the free videos. That's it. Let's move to the next question. Let's move to the next question. Yes. Here you go. Don't think that it's a tough question, numerical type questions, or I need to have a calculator and all. Don't think too much on this. It's a simple concept. We already got the answers. We already got the answers from different people. Okay, your time's up. Your time's up. A 400 by 200 volt transformer has a per unit impedance, Z per unit is given 0.05. Tell me guys, this per unit impedance, is it with reference to high voltage or low voltage? I'm asking you. Is this per unit impedance with respect to high voltage or low voltage? Because he is asking about, this is a different thing from high voltage size required, whatever it is, but this per unit, this is full stop here, means this statement is over. So is this with respect to high voltage or low voltage? Tell me. Yes, Durga Prasad, you're right. Yes, Raj, you're right. Amazing. Per unit impedance will be same. With respect to primary, with respect to secondary, per unit impedance is same. Per unit resistance is same. Per unit reactance is same. Not the equivalent reactance and resistance and impedance. Per unit values are same. Keep that point in your mind. Okay. So this is this. Now HV side voltage required to circulate a full load current during a short circuit test. Means during a short circuit test, I'm giving at the high voltage side, which is of 400 volts, rated volts is 400 volts. This is the equivalent resistance and equivalent reactance. Now I am conducting a short circuit test. Under the short circuit test, how much voltage I should give? If you give 400 volts here in the short circuit condition, boom, Diwali, big Diwali, it's a blast of transformer. Okay, so you cannot give a full voltage, you should give a reduced voltage. Now how much is the reduced voltage to allow the rated current? That is equal to this per unit voltage with respect to rated voltage, means simply 0.05 per unit into rated voltage is how much? 400. 400 zeros and these two decimals gone. 5 into 4, 20 volts. Answer is B. Simple. Simple. Yes, you're right. You're right, Chandrabab. Let's go to the next question. I think most of you answered very nicely, except some people. Yeah, let's give it for everyone. Great. Next question. Nice. Very good. Time's up. Time's up. Time's up. Let's read the question. And before we go to this question, I think I told you every time, I've been saying for every question when voltage regulation is coming, guys, try to pay attention, try to learn the concepts of voltage regulation thoroughly. It will help you in transformers, in synchronous machines, in power systems, even in DC machines also, DC generator also. This voltage regulation will follow you. Wherever you go, this voltage regulation will follow you. V and animated V curves will follow you. Armature reaction concept will follow you. These are the key concepts which you should never miss. Okay, so pay attention on these key aspects along with every other aspect. Now, a two-winding single-phase transformers. So what is this? A two-winding single-phase transformer. Explicitly he has given two-winding single-phase transformers. Is there any one-winding single-phase transformer also? If that is also there, what is that name? What do you call that as? What is this one winding single phase transformer? Have you ever heard of one winding single phase transformers? Kya baat hai bhai? Tritesh, you're right. Durga Prasad, you're right. Ravi, you're right. In a smarter way he has written. Ah, Sampad, you're right. Auto. Because you don't have to give a full details. It will be understood very nicely. Okay. Okay. Yeah. Nice. So this is auto transformer. This is auto transformer. Okay. Now has a voltage regulation curve. Just try to keep this curve. Voltage regulation means I'm not asking you to recall everything. Try to keep the curve. Curve is this is a curve. This is a curve. He said this is unity power factor. Middle is not a zero. Middle is unity power factor. Careful, babes. This is lagging. Zero here. This is leading. Okay. 4.5% at full load and unity power factor. At this here, it is a 4.5% because it is a percentage voltage regulation. At a full load and a 0.8 power factor, lagging means this side definitely curve is going upper than this, above than this. So definitely value is more than 4.5. You don't have to do any math over here. You don't have to do any math over here. Just with this amazing lovely diagram, you will be able to answer it. Suppose if he would have said 0.8 power factor leading, definitely would say less than 4.5. Less than 4.5. Somewhere close to 0 you will get. Maybe negative, maybe positive. Nobody knows that. Nobody knows that. Okay. Yes, Chandra Babu, you're right. Here, this value is equal to per unit resistance. What is this value? At what power factor will get? At what power factor will get this? I think you have to know all this. Okay. Let's go to the next question. Yes, you're right, per unit impedance. Amazing, guys. Polytechnic lecturers. Guys, I don't know whether you're ready or not. 99 vacancies are there. I think everybody answered this one also. Very good, guys. Very good. Amazing. 0 voltage just not have seen. Yes, it is possible at any load. Full load, half of the full load, any load it is possible, but power factor must be possible at leading power factor. Just now we have seen this curve. This curve says everything. This curve says everything. Okay. Great. Anyways, you just follow the channel, guys. Follow the channel. We'll share everything in the WhatsApp channel. It is pinned in the comment. Okay. Yeah. Let's just go to the next question. Great. We got mixed answers. We're getting some mixed answers, but some people are exceptionally good. Okay. Nice. Wow, kya baat hai. Krantikumar has nicely given elaboration. I think with his explanation, I don't have to say anything. If you understand this line, what he's saying, it's amazing. Great, Krantikumar. Okay, time's up. Let's see. If the iron core of a transformer is replaced by an air core, then the hysteresis losses in the transformer will be hysteresis losses and eddy current losses. They are combinedly called as, tell me, they are combinedly called as, tell me, I want to hear it from you. Drop them faster. They are combinedly called as what? Hysteresis and eddy current, they are combinedly called as, very good. I want everybody to drop it. Shake it. Break it. They are combinedly called as iron losses Because earlier iron was used as a core. Now iron is not used as a core. Different cores are coming because of the material science. Advancements in the material science, different materials are coming. So core could be made up of not necessarily iron. Hence they are calling this one as not iron losses. They are calling it as a core losses. They are calling it as a core losses. Now there is no core. There is no core. Air core means non-magnetic core. Then no core losses. Simple. With the basic terminology itself, with the basic common sense itself, you will be able to answer. You should be able to answer. Answer is becomes a 0. And technically speaking, Krantikumar has amazingly given this explanation. If you just talk about a BH curve, boom curve, BH curve. What is a BH curve? It will be linear, lovely linear if the core is an air core. No saturation, no residual flux because no core. There is no retentivity property, no coercivity property, nothing is there. It's a lovely linear. Area under the curve, BH curve is 0. Hence the hysteresis losses are 0. Even the eddy current losses are 0. Hence the total core losses are 0. It's not only valid for hysteresis, it is also valid for eddy current. Okay. Yes, you're right. Then why not we don't use these cores? Why not we don't use these air cores? Can somebody answer to this Sampath question? He got a beautiful question. I think Sampath himself can answer this question, what he's saying. But yeah, it will be great if somebody else can answer it. No, question is not that. Question is why? Oh, it got deleted? I don't know why. Kuch kiya? Okay. That's a beautiful question. Yes, Tritesh has answered it correctly. It is about the magnetic path. You're right, Brahmateja. Yes, Brahmateja. Congratulate Brahmateja. Brahmateja is the one who got the job in the previous live session. He has finished. He secured the job. He received the offer letter today itself. Today itself he received the offer letter. Congratulate. Every one of you congratulate Brahmateja. Great. Congrats, Brahmateja. And next person could be, you could be that next person. If you are performing good, if you are a PiSquare student, then you could be the next person who will be getting a job right from the live, YouTube live. Okay, core job. Anyways. Yes, as he said rightly, core losses are less, but magnetizing current will be very high. Magnetizing current will be exceptionally high if you use air core transformer. That will draw huge amount of current from the supply. Why magnetizing current is high? Because reluctance. We know flux is equal to MMF by, MMF is a function of current, MMF by reluctance. Reluctance of the air is much low compared to iron. As this is low, no, this is high. Reluctance is opposition. Opposition is high if it is an air core. So for the same MMF, you will get a lesser flux. I cannot control the reluctance on the fly. So to have higher flux, I will have to increase the MMF. Number of turns also I cannot control on the fly. The only thing which I can control in this MMF is a current. It will draw dangerously high current. It's not dangerously high current. It will give a huge electricity bill to you if you want to enjoy already expensive electricity bills in Andhra Pradesh. If you want to enjoy even higher electricity bill, you use air core transformer. Okay. Yeah. Recently, when I went to home, I saw these electricity bill charges and all. I mean, it's too much of extra charges they're adding. Anyways, that's all different thing. Let's move to the next question. Bang. He's saying something. In what context? I'm not sure. Okay. Only one person has answered. What happened to the others? They're sleeping. Okay. Air core context. Fine. Ravi answered. Tarun answered. Tritesh answered. Those whoever has answered, they're all right. I'm waiting for others to respond. I think everybody's maybe busy at booking tickets, movie tickets. Okay, let's get to this as time is up. A 1:5 step up transformer. Step up, step up, step. 1:5 transformer has 120 volts across the primary. Secondary, what will be the secondary value? 5 times more. 500 plus 100, which is a 600. 600 volts. If it is a 120 volts, it will be 600 also because it is a 100% efficient one. Low losses, ignore everything else. 100% efficient. So 120 volts when you are giving it, you will get a 600 volts because it is a 1:5 ratio. Now you are connecting, careful guys, a 600 ohm resistance across a secondary. So current in this will be 1 ampere. If this current is 1 ampere, the question is what is the current in this? Definitely greater than 1 ampere. Definitely greater than 1 ampere because a step up voltage, this power is how much? 600 into 1, it is 600 volt ampere. 600 volt ampere. So here this current must be high. How many times high? 5 times. This is 1 ampere. Current on this side will be 1:5. Current will be 5:1. Current will be 5:1. Why it is 5:1? Because N1 by N2 is equal to E1 by E2 is equal to I2 by I1. So if the voltage ratio is 1:5, current ratio will be 5:1. This is 5, this is 1. Answer is 5. Such a simple question. Without any math, you should be able to do it. And Krantikumar has went a one level above. I must appreciate Krantikumar. Why? Because he amazingly said one more point for you to keep it noted. For you to keep it noted. Means this current is a 5 ampere. This current is 5 ampere. Means this entire system is acting like you are connecting a 120 volts supply to a 24 ohm resistance. Then this is driving 5 ampere. This is driving 5 amperes means what? Effectively the resistance is 24 ohms. That's what he is trying to say. And this is what the application of a transformer, or this is one of the uncovered or maybe underrated application of a transformer. What is that? One of the underrated application of a transformer, like a PiSquare Academy underrating. This is also underrated. Impedance matching. This concept is called as impedance matching. You are connecting 600 ohms, but it is considering with respect to source, this is just 24 ohms. Just 24 ohms. Now, this resistance, if this is fixed, 600 is fixed, but I want to have this effective value, I want to vary this effective value in spite of this value fixed. This is fixed. I want to control this 24 effectiveness onto the primary side. Then you simply control this ratio. That is what the concept of impedance matching. Understood? That is what the concept of impedance matching. Isolation, yes, you're right. Isolation also another concept. This impedance matching concept, I think CC configuration in analog electronics. In analog electronics, it will give huge advantage of this impedance matching. Not only in analog electronics, in electrical also it have a great impact. Okay, I hope you got it. If you understood what I'm saying, let me know in the chat or maybe through likes or whatever it is. You understood the point what I'm trying to say, babes? Okay, great. That's it. Now let's go to the next question. Easy question, simple question, superb question. Trish is asking about induction machine. We'll discuss that during induction machines, Ria. Wow, Raj has a fantabulous question. We'll come to this question. Just wait, Raj. I'll take up this question. Anyways, your time's up. Now, let me just go to this particular question. What the question says? The question says, a 10 kVA, it's simple, a 10 kVA, 400 volt by 200 volts, a single phase transformer with 10% impedance. It has a 10% impedance. Means percentage impedance or per unit impedance is how much? 0.1 per unit impedance. Our position is this much. Draws a steady short circuit line current of. It's a single phase, so it's fine. So I'm assuming it's nothing is given, high voltage or low voltage side. Okay, so let's take it the same as it is, and we'll figure it out. I'm taking 4000 here, sorry, 400 here, 200 here. It's a 400. It is 200 volts. Okay, now it is short circuited and the transformer impedance is 0.1 per unit. Tell me what is the rated current in the high voltage side. In the high voltage side, what is the rated current? Rated current is, this is a power S, apparent power 10,000 by 400. This is 25 ampere. Am I right? Correct me if I'm wrong. Yes, this is a 25 ampere. This is not a short circuit current. This is a rated current. Now, from the previous concepts what I discussed, to drive this rated current, how much voltage do I require here? 40 volts is required because 400 is rated, 0.5 per unit, 0.1 into 400, which is a 40. If I give 40 volts, this will drive 25 ampere. Now I am increasing, I am giving 80 volts. This is double, current will be double because it's a proportional. Don't think that a transformer will not obey Ohm's law. We have a video on that. Transformer definitely obeys Ohm's law. Transformer definitely obeys Ohm's law. Then don't ask a question, sir, if transformer obeys Ohm's law, how current is changing and all. Already we have a video on that. Does transformer obeys Ohm's law? Just check in the PiSquare, you will get a clear idea about it. Okay, 80 volts, so current will increase to 50. So if this is 10 times, this will increase to 10 times. This is increasing to 10 times. This will increase to 10 times, 250 ampere. 250 ampere. Answer is 250 ampere. Now, we got a question. And that question is already addressed. Raj had an amazing question. That amazing question had an amazing reply by Sampath. Isolation transformer. Isolate two circuits and provide protection for the load. That's right. That's right. Isolation transformer used for capacitor coupling of winding. Guys, these isolation transformers, if you want to enjoy, if you want to feel the beauty of these isolation transformers, mainly when you are dealing with power electronic circuits, you will directly feel it. You will directly feel what is the use of this high voltage transformer or isolation transformer. Why you need isolation transformer there in power electronics? Why I'm saying in power electronics? Because we use in power electronics 1:1 transformer at times. What is that? 1:1. Matlab this is neither increasing voltage nor decreasing voltage, neither increasing current nor decreasing current. Then what is doing, sir? It is doing nothing. Then if it is doing nothing, why do we need a transformer on the first go? That is for isolation purpose. Now, why do we need isolation? I think that's going to be a little lengthy one, but if you come into this power electronics zone, already they are explained in the courses. There you will understand, yes, this is the reason why you require isolation. Okay. Anyways, power is transferred from primary to secondary. Then what is meant by isolation? It does not shock humans. No, dear. No. Here, don't think that there is a great isolation in this particular case of power electricity. There is no, it can serve isolation purpose. It can serve, it is not serving right now isolation purpose. You will get a shock. Okay. But for protection purpose, that is a completely independent circuit. This primary is independent, secondary is independent. In terms of protection, there you have primary have a different circuitry, secondary will have a different protection circuitry. Okay, in that sense. Anyways, to understand that in a lighter way, first you focus your attention onto this power electronics, how it is isolating, because in power electronics, you are actually controlling high voltage and high currents with the help of small control signal. So there you require isolation, definitely require isolation. Okay. So in that application, you have to focus on the isolation purpose. In case of analog electronics, you have to focus on impedance matching. As electrical engineers, what we always and every time care is up and down. Voltage and current. That is it. Great that you understood. Let's go to the next question and the last question for this session. Okay. So I want you to answer this in the chat. In the comment, I want you to answer. Okay. Take a screenshot, try to answer this because I already described this in the previous questions. So you take your time and answer it. We are moving to the next question. No, next question will wind up the session. Yeah. Okay. So this question is not answered, right? I have not answered this. Okay, script one. Sure, fine. This is something new, I think. Polarity test. About the polarity test. How many of you know polarity test? polarity test is necessary for a single phase transformer shown in the figure, okay, to correctly determine dash of a transformer, shunt branch parameters, transformation ratio, series branch parameters. For finding out branch parameters, why do we require this polarity test? No. To make dot notations, you're right, absolutely. To make dot, where to place the dot. Already here a winding pattern is clearly known, because from the below diagram, you know, winding is, okay, if the dot is here, so dot will be here over here, okay, because current is going this way, it goes up, and now current is entering at the dot. If current is entering at the dot, it's the same direction, so yeah, dots are here because winding pattern is known. You don't have to do the polarity test. But suppose if the pattern is not given, you want to find the polarity test, where to place the dot. Absolutely right by Raj. Which of the shunt branch parameters finding? We don't require polarity test for the shunt branch, because in OCSC test you don't have to go for it. Transformation ratio, I don't need polarity test for transformation ratio. Series branch parameter, that can be found from a short circuit test. I don't require for series branch parameters also the polarity test. So I don't think we'll be using this polarity test on all these options. Any of the above characteristics. Now, as these three are not valid for me, so this is not even a valid option. Okay, so I'm just giving information. Transformation ratio, why do we need a transformation? For transformation ratio, why do you need polarity test? You simply, you will connect here some voltmeter, you will connect another voltmeter, you'll apply some voltage, you will check what's the ratio. It doesn't require a polarity, right? Whether it is a positive or negative, it's not DC, it's AC. So you don't require. Yeah, maybe some options, maybe none of the above should have been here. If none of the above is there, then that could be the right answer. Anyways, with this, I think, yes, you're right, Vamshi. For parallel operation, you definitely need polarity. You definitely need dot and cross. Thereby, you will know whether, that's a dangerous case. If you don't know polarity for parallel operation, it's going to be a blast. Okay, so there you will take measures properly. You're absolutely right. There you require. Okay, good. Anyways, with this, let's end the session. Soon I'll come up with another video where I'll be discussing about the notification of polytechnic lecturers. Okay, till then, guys, if you have anything to ask, you can give regarding this question series. You can give it in the comment. We'll try to answer this. And if you want to watch the free videos, you can always visit our website, which is given in the description. Check our courses. Free videos are available for every course. Some free videos are available. Online test, try to appear the online test. Mostly we'll try to even increase the free or online test, so that you will be able to check your performance without paying anything. Okay, we'll try to do that. Okay, and as I said, shortly we'll be, as some people are already testing the AI bots, chatbots, where they are asking questions, they are clearing their questions through our artificial intelligence. We trained specially from our inputs. Some people are enjoying it. We'll try to extend that to everyone else. We'll try to announce it very shortly, maybe in the New Year or maybe for the Pongal and everything. Okay, you can visit our website to buy the courses and all. Okay, and if you have anything to follow, suppose you are having updates, these job updates, regular updates, for those updates, nothing to worry. WhatsApp channel is given in the link. Just follow that WhatsApp channel. Free videos. No, sir, I don't want to pay for it. I have money. I am very rich in terms of buying a dress. When I'm watching movie, when I'm enjoying, I'm very rich. But when it comes to learning, I am very poor. I will not spend money, but I want to crack best things without paying a single rupee. In the chat, in the WhatsApp, you have in the description, you have a WhatsApp link. There, you just ask us, I want a free video. Don't be shy on asking for free videos. It's not that I'm saying PiSquare videos will be given to you for free. Okay, but we'll definitely give you, we'll curate some of the best free videos available out there. We know you're very poor when it comes to learning, so we'll pass that videos to you for free. Okay, that's end of this session. RRB, JE, Railway, which level preparation is required? I think we are getting a notification soon. We'll be getting a notification shortly on this JE. Okay, and this book, what we have given here, there is a book here. If you just follow this book is level 1 questions you will have in this book, physical book, it will be delivered to you. It's a level 1 questions will be there for JE. You can follow this book. This is pretty much enough, okay, for JE level. Okay, that's what I can say. Okay guys, catch you in the next session. Have a good time. Bye bye.